Hello everyone! In the last video on Net64 technology, I talked about the IPv6 evolution process. As we evolve from IPv4 to IPv6, IPv4 and IPv6 network services will coexist for a long time. The dual-stack technology enables devices to run both IPv4 and IPv6 services. It allows devices to communicate with IPv4-enabled and IPv6-enabled devices using IPv4 and IPv6 respectively. However, if only the dual-stack technology is used during IPv4 to IPv6 evolution, all nodes must be enabled with this technology in order to maintain both IPv4 and IPv6 networks, causing complex deployment and difficult operation and maintenance. Emerging carriers cannot obtain new IPv4 addresses due to IPv4 address exhaustion, and deploying dual stack involves high costs. Furthermore, the evolution to IPv6 means that most new services and new networks are based on IPv6. This is why dual stack has limited applicability today. So how can existing IPv4 users access IPv4 applications over an IPv6 bearish network? This is where DS-Lite comes into play. DS stands for dual stack, and Lite stands for lightweight. DS-Lite is a lightweight dual stack technology. So what does Lite signify? Unlike dual stack, DS-Lite requires only devices at the border of IPv4 and IPv6 networks to support dual stack and the intermediate nodes to support only IPv6. DS-Lite is a combination of IPv4 over IPv6 tunneling and NAT. IPv6 networks can directly carry IPv6 services, allowing IPv6 users to access IPv6 internet servers. IPv4 over IPv6 tunneling is used to carry IPv4 services on the IPv6 network, and NAT is performed on the CGN devices to translate between public and private network addresses, so that IPv4 users can traverse the IPv6 network to access IPv4 internet servers. On a network running DS-Lite, two new rules are introduced: B4 and AFTR. Both rules support dual stack. Before, the creator of an IPv4 over IPv6 tunnel is usually implemented on CPEs. AFTR, the terminator of an IPv4 over IPv6 tunnel, is usually deployed on CGN devices. It decapsulates IP packets, performs NAT, and records NAT mapping. Now let's look at how DS-Lite is implemented. IPv6 users can access the IPv6 internet server through normal IPv6 forwarding. When an IPv4 user accesses an IPv4 internet server, the B4 adds an IPv6 packet header into the IPv4 packet. The source address in the IPv6 packet header is the B4 address, and the destination address is the IFTR address. The packet is then forwarded over the IPv6 network. After receiving the packet, the AFTR decapsulates it and removes the IPv6 header. It then translates the private network address and the port number in the IPv4 packet into a public network address, and the corresponding port number to communicate with the IPv4 server. After the response packet returned by the IPv4 server reaches the AFTR translates the public network address and port number into the private network address, and port number based on the NAT mapping table, and adds the IPv6 packet header. Next, the packet is forwarded to the B4 through the IPv6 network. Finally, the B4 decapsulates the packets and sends to the IPv4 user. In this way, the IPv4 user can use a private network address to access the IPv4 internet server. DS-Lite can also function as a server. You can configure the mapping between the private IP address of server plus IPv6 address of B4 and the public IP address of the server. The AFTR translates a public IPv4 address of a packet into a private IPv4 address based on the mapping and adds an IPv6 header into the packet. The packet is then forwarded over the IPv4 network, decapsulated on the B4, and sent to the IPv4 server. In this manner, IPv4 Internet users can traverse the IPv6 network to access IPv4 servers. NET provides a NET ALG technology to translate IP addresses and port numbers in the payload of application layer protocol packets to ensure normal running of application layer protocols. As a combination of IPv4 over IPv6 tunneling and NET, DS-Lite plays a similar role by providing the DS-Lite ALG technology. Take FTP as an example. The FTP client on the IPv4 network needs to traverse the IPv6 network to access the FTP server on the IPv4 Internet. After a packet is encapsulated and decapsulated by the B4 and AFTR, respectively, the AFTR translates the private IPv4 address in the packet header into a public IPv4 address, but does not translate the IP address in the payload. After receiving the packet, the FTP server regards it as an invalid packet and cannot communicate with the FTP client. If DS-Lite ALG is configured, the IP address in the payload is also translated, and the two parties can then communicate. DS-Lite ALG cannot solve the problems of all application layer protocols. For example, complex protocol packets like HTTPS packets cannot be translated. To summarize, DS-Lite enables IPv6 networks to carry IPv4 services. In the last video, we talked about limitations of NET6.4. DS-Lite, a combination of IPv4 over IPv6 tunneling and NET, has similar limitations. First, the CPE need to be upgraded and special boards or devices need to be introduced for NET. All this is costly. Second, packet decapsulation and NET increase the device processing delay, making it unsuitable for delay-sensitive services. Third, a large amount of tunnel data needs to be maintained, increasing network overheads and potentially affecting network quality. Fourth, some limitation of NET, such as difficulty in source tracing and the inability to translate complex protocol packets like HTTPS packets, also exists in DS-Lite. Transition to IPv6-only networks will resolve all the processing issues. With the support of DS-Lite, we expect the transition to IPv6-only networks to be a quick process. That's all. Thank you so much for watching.